At this point, you've already learned how your altimeter works and how to read it. In fact, you know so much about these instruments right now that you could probably build one of these things yourself. Well, almost. Now we're ready to learn how to make the altimeter provide us with the correct height above sea level. And as you'll soon see, the altimeter can lie to you if you're not careful. So you have to know how to prevent it from lying. It's like having the neighbor kid I caught lie to me one time. I said, "Bobby, don't lie." He goes, "Why not?" And I said, "Because the devil's going to get you." Then he looked at me and said, "Why? I'm doing what he wants." Well, fortunately, the altimeter is easier to discipline. First, you need to know we're concerned with 4 different kinds of altitudes here. In remembering these altitudes, pay attention to their specific names because this will give you a clue as to what the altitude means. It's like asking, what are the Canary Islands named after, or who's buried in Grant's tomb? So let's start with the term indicated altitude. If I ask you what time it is, you'll look at your watch and you will tell me what the hands indicate. Whether the time is right or not is irrelevant. You'll simply look and say, it's 3 o'clock. Or if you're from a rough part of the country, you'll look and say, it's gone. The indicated altitude is simply what the altimeter hands indicate, and that's it. Just read the altimeter hands, what they point to, that is the indicated altitude. True altitude is your actual height above sea level. Think about the word true. Something is true only after you correct it for errors. So if we take what the altimeter indicates, the indicated altitude, and correct it for variations in non-standard pressure and temperature, then we get something that reflects our true height above sea level, otherwise known as true altitude. Absolute altitude is the actual height above the surface. Of course, if you were crossing a mountain range, your absolute altitude would change rapidly. If you were over the ocean, then your absolute altitude would be the same as your true altitude. The last definition is so simple that it's confusing. It's like me asking you, what is the color of the red light on the tail? Huh? The last altitude is called pressure altitude. And it is what the altimeter reads when you set the value of 29.92 in the altimeter window. You'll learn more about pressure altitude later on. Now it's time to learn a little more about how an altimeter works and how to correct for those non-standard pressure and temperature conditions we mentioned earlier. It's important to know that at the altitudes we fly our small airplanes, the atmospheric pressure drops at a remarkably constant rate as we climb. In fact, it decreases almost exactly 1 inch of mercury for every 1,000 feet of altitude gain. This makes it easy to take a pressure gauge and mark it off in altitude calibrations of feet. If the pressure gauge shows a decrease of 5 inches of mercury, we know we've climbed approximately 5,000 feet. A 1 inch decrease in pressure means we've climbed approximately 1,000 feet. So this predictable decrease in pressure as we climb is actually the good news. The bad news is that the pressure also changes in the horizontal direction from place to place because of variations in the weather. Fortunately, the bad news won't bother you because you have already been correcting for it. That's what you've been doing when you put the current altimeter setting in the window. When you place the current altimeter setting in the window, you're telling the altimeter what the pressure is at sea level for whatever place you happen to be at the time. This provides the altimeter with the starting point to counting those 1 inch of pressure or 1,000 foot drops. Even though the pressure at sea level may change from place to place, the altimeter will read our altitude because the atmosphere still decreases its pressure the same amount for every 1,000 feet of altitude gain, regardless of your location on Earth. Yes, it even works that way in Hollywood, where, I was thinking the other day, if aliens from space landed, how would we know? Perhaps you've already noticed that when you change the numbers in the altimeter setting window, the hands change position too. The hands are mechanically connected to the altimeter knob as well as the numbers in the window. What you may not have noticed is that the numbers in the window and the numbers that the altimeter hands point to change value in the same direction. In other words, when one value goes up, the other value goes up. When one value goes down, the other value goes down. This is a very helpful relationship to be aware of when we talk about altimeter errors. You know, your altimeter is a hard-working and pretty reliable device, but it can have errors unless it gets a little help from an operator every now and then. If current sea level pressure settings aren't entered into the window, you could have an error in the altimeter's reading as you fly towards an area of lower pressure. Let's say you are here on the diagram where the pressure at sea level is 30.00 inches or 30 inches. You take off and climb to an altitude of 1,000 feet. Now your indicated altitude is 1,000 feet. Because you are at 1,000 feet, the altimeter senses an outside static pressure of 29 inches and thus reports this to you as an indicated altitude of 1,000 feet. As long as you keep the altimeter indicating 1,000 feet, you are at a level where the pressure is 29 inches. But look what happens to the 29-inch pressure level as you move towards an area of low pressure. If the reading stays at 1,000 feet, and if the altimeter setting isn't reset, you'll find yourself moving closer to the surface. In other words, you'll find that your true altitude, your height above sea level, will be less than your indicated altitude, what the altimeter indicates. A wise old pilot rhyme goes, "From high to low, look out below." Why? Because you are lower than the altimeter says you are. The errors are easy to calculate with a little basic math. Don't worry, it's basic math. And I know that one recent study indicated that 52% of Americans have trouble with math. Imagine that, nearly a third. Suppose you take off from an airport where the altimeter setting is 29.85, and you fly to an airport where the altimeter setting is 30.15. What is the altitude error you'll have if you don't reset the altimeter? First, find the difference between the two settings. 30.15 minus 29.85 gives us a difference of 0.30 inches. Since 1 inch of barometric pressure change equals 1,000 feet, then 0.3 inches of pressure change must equal 0.3 times 1,000 feet, or 300 feet. Your altitude is off by 300 feet, but is it 300 feet high or low? Just picture yourself in the cockpit with the incorrect setting in the altimeter window. Now mentally reach out and dial in the correct number, which is bigger than what is in there right now. You know the hands must also move to a higher number, so you are really 300 feet higher than you thought you were. Or you can use the memory phrase, low to high, clear the sky. You went from low pressure to high pressure, so you were higher than the altimeter shows. Now you know why they say clear the sky. In other words, your true altitude is greater than your indicated altitude. The high to low rhyme also works for temperature variations too. You know, altimeters were meant to work when the temperature at sea level is a standard 59 degrees Fahrenheit. Any variation from standard temperature actually causes the atmosphere to change its height. On days when the temperature is colder than standard, the whole atmosphere actually gets lower. So what happens if you're flying from an area that's warmer than standard to an area that is colder than standard? Well, we can use the rhyme, from high to low, look out below. In other words, we're going from high temperature to low temperature, then we'll be lower than that which our altimeter indicates, or our true altitude will be less than our indicated altitude, even though, in this case, the correct pressure is set into the window. And since there's no lid on the atmosphere, when the temperature rises, the whole atmosphere gets taller like this. The altimeter has no built-in correction for this, but in normal operations, it doesn't pose much of a problem. It does mean, however, that it'll be a very rare occasion that your true altitude and your indicated altitude are exactly the same. So when will the indicated altitude and true altitude be the same? Well, if you forget variations from non-standard temperature, then setting the altimeter setting in the window will allow the true altitude to be the same as your indicated altitude. Or if you took your altimeter down to the seashore between tides under the standard conditions of 29.92 inches of mercury and 59 degrees Fahrenheit, then all the altitudes, indicated, true, absolute, and pressure would be equal. By the way, it wouldn't be a good idea to try to check this out in your Skyhawk because the maintenance gang reports that salt water causes a lot of corrosion on disc brakes. But after this lesson, when you taxi out for takeoff, you know what errors lurk in your altimeter and how to deal with them for a safe flight. Oh, that standard conditions business, you'll learn more about that later.